Okay, we are working with Math Expressions, Chapter 1, Lesson 9. And today what we're going to be working together with, or for tomorrow, is practicing writing equations and also working with algebraic chains. Ooh, big word there. I know some of these things as far as when we were talking about variables, solving with parentheses, these are big concepts to understand. I really want you guys to know how impressed I am with how you're tackling some of these things that we're going over. Just really a great job that you're doing. And remember that even though I'm kind of showing you one way of doing it, that there also are some other ways to write these equations, and I'll kind of go through that as we're watching the video. So let's start with just writing equations. And for some of us, this is where math gets tricky because maybe reading isn't our strong point, but we can work with numbers. So kind of looks overwhelming when we have all of these words on our paper. And you know what? Just to kind of slow that down for you, let us focus on one situation at a time. All right. Molly's family stayed at the cabin for 4 days. Then Tonio's family moved in and stayed there 3 times as long as Molly's family. After that, Jenny's family moved in, stayed 4 times as long as Molly's family. How many days did these families spend at the cabin all together? Wow, a lot of information in that story situation. So we're going to start out with Molly's family. And Molly's family stayed at the cabin for 4 days. And we're going to break it down even more. So let's get all the important details out. Then we have Tonio's family. And Tonio's family is going to stay 3 times as long as Molly's family. So 3 times Molly's family, or 3 times the 4 days. And then we have Jenny's family, and they stayed 4 times as long as Molly's family. So Jenny's family stayed 4 times as long as Molly's family. And maybe I should put on the side here, what we're doing is the 3 times the 4 and the 4 times the 4. So drawing those pictures out, or writing the important details out on the side, kind of helps us get an idea and organizing it out. Going right to the equation is not what I'm expecting out of fifth graders. Even the adults have to do kind of a rough draft or an idea of what's happening before they can continue on. If we were going to put that in an equation, the one way that I'm going to try and push you towards putting it is um, putting it within parentheses and writing it out like this. So we have Molly's time plus, pardon the interruption in the background, plus Tonio's, which is the 3 times 4. And then we're going to add that to Jenny's family, and that's 4 times 4. And that's going to give us our total amount of days. If you're doing it over to the side, some of you might go straight into the equation and say something like 4 plus 12 plus 16 equals D. And that is okay too, because you've already realized that you're multiplying and solve those multiplication situations on the side there. So either way, if you can write the equation like that, that's great. But if you're writing the equation with the products to add them up, that works also. So adding those all together, doing it in our head we can do the more comfortable we get, but we might want to line them up on the side. Remember, when you're adding multiple digits, that you want to make sure that you're lining up place value. So 6 and 2, that's 8, and then 8 and 4, that's going to be 12. 2 is down, carry the 1, 10 to the next place value. 1, 2, 3, we have 32 days. I always just want to encourage you guys that doing the work on the side or drawing pictures is excellent. I want to push you towards, like I said before, I want to push you towards being able to write an expression with parentheses. But if you're able to recognize what's happening and then you're writing it out this way, that is just fine. Let's do one more here, and then we'll move on to algebraic chains. All right. Fallbrook School has 5 computers. Maplewood School has twice as many computers as Fallbrook. Pinewood school has 6 times as many computers as Maplewood. Okay, Maplewood School. How many computers do these schools have in all? Okay, some tricky stuff there. So what we want to do is maybe on the side organize our information. So we have Fallbrook School, we have Mapleville School, and then we have Pinewood School. So we want to figure out how many computers each, and then we're going to combine those because the last question, remember, is the important one, how many in all. So Fallbrook School, right away, we already know they have 5 computers. And then we get over to Maplewood School. Maplewood School has twice as many computers as Fallbrook School. Okay, so twice as many, so 2 times what Fallbrook School has. All right. And then we have Pinewood School has 6 times as many computers as Maplewood. Okay. So Pinewood has 6 times as many as Maplewood or Mapleville. So we want to figure now how many they have all together. So eventually, from the beginning to write the equation, an algebraic equation, we would take this information, and this is what I hope to push you to, and we would start with 5, and we would add 5 to 2 times 5, and then we would add to 2 times 5, we could put in parentheses again 6 times, and then in parentheses again 2 times 5, and then double parentheses the end, and say that's going to equal C, how many computers in all. Very tough concept. But if you're able to work with what we did over on the side here and realize that Fallbrook has 5, and then we're going to add Mapleville, and 2 times 5, twice as many as 5 is 10. And if we know that this is 10, that Maplewood is 10, and we know that Pinewood is 6 times that, we can say 6 times 10, we're going to add 60. And then that's going to equal how many computers we have. So over on the side, I know that when we are in the tens, we can tend to do mental math. But for those of us that are questioning it, let's do it on the side and line it up vertically. Starting with the ones, 5, 6 tens and 1 10 is 7 tens. So we have 75 computers. So really putting all the information that we have out on the side and trying to write it in an algebraic equation. But if we're going straight to this, that is definitely acceptable. And knowing that you're solving for how many computers and able to recognize that it's 5, 10, and 60. Please don't be discouraged if that's where you're going to go with it. Let's get out of this. All right, here we go. Let's scroll down to the bottom. And what we're also going to talk about today, and we're going to get a little bit tough with our topic here, so be ready to ask questions tomorrow. Know that it's okay to ask these questions. An algebraic chain. Know that, remember, you're in 5th grade. I didn't see algebraic chains up until high school, so this is really, really tough stuff, and you should be proud of yourself for where you're getting with this. So what we're going to do is find the unknown number in each equation. We can also write a 1 in front of an unknown that is alone if it will help you. All right, so this first equation that we have here is a plus 3a equals 36. When we have a variable like a here, it's the same variable. That means if in this equation, a is going to equal the same number. Okay, so whatever we find out a to be, it's going to fit here and it's going to fit here. So when they're in the same equation, a is equal to the same. So if we have 2 spots where we have a, we can add those up and end up with 4a equals 36. When they said here you could put a 1 in front, one in front of an unknown, they mean that you can put a 1 in front of the single a to realize that there's only one a there, and then we have 3a. So 1a plus 3a is 4a, and that equals 36. We know from our talking that when we have a variable next to a number with nothing in between, that means to multiply. I'm putting that little dot number, that's another sign of multiplication. All these signs, remember, we don't cry, we just multiply. and that equals 36. So what we say in our head is 4 times what number gives us 36. Okay, 4 times what is 36? I know that 4 times 9 is 36, so A equals 9. How that works then into our equation is we can say 9 plus 3 times 9 equals 36. That's kind of putting it back up into here, and that is right because we have 9 times 3 is 27. 27 plus 9 is 36. Okay, moving on to the next one. B plus 4b plus 2b equals 28. Same variable, b, 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 and we're adding those up, so we're simply going to add up our numbers to see how many b's we have. So you can put a 1 in front of the single variable b to help you. So we have 1b plus 4b plus 2b, so we have 7b equals 28. Remember that 7 next to a variable means to multiply. I'm going to do another symbol for multiplication, the x equals 28. I could just talk about that for a second. The reason that we tend into multiplication not use, or in algebra to not use an x, is because sometimes x is your variable, so it can be confusing. So that's why we have things like a dot, or we put in parentheses, or we just put the letter right next to the number to represent multiplication, because if we put an x in there, some people might think that's a variable. So 7 times, going back down here, 7 times what number is 28? Well, I know that 7 times 4 is 28, so b must equal 4. Okay, moving on over here, 5c plus 2c, all the same variable. I'm going to put a 1 in front of that c to help me remember. I'm going to add them up to see how many c's I have. 5c plus 1c, 6c, plus 2c is 8c. Okay, so 8 times a number gives me 16. Well, c must equal 2. Okay, if you know, as a good mathematician, check that to see if that's right. Well, 5 times 2 plus 2 plus 2 times 2, does that equal 16? Let's check it out. 10 plus 2 plus 4. 10 plus 2 is 12, plus 4 equals 16. Yes, we did get to 16. Let me check my time here as we're moving on. Oh, goodness, Mrs. Freeman. Ugh, I need to talk faster. All right, going to the next page. See, this is what I always hate. We get to the second page, and then I just feel like I'm burning through it. So I'm going to talk quickly about this up here, and then know when you get to class tomorrow that we're going to investigate that more before I send you on with any work. So just kind of getting a good idea of where we're at here. So we're going to make word problems tomorrow with algebraic chains, just like we did before. Kind of taking in the word problems that we started out with this lesson, those algebraic chains, and building up from that. So there are 3 times as many brown eggs as white eggs. Altogether, there are 24 eggs. How many eggs are there of each kind? Okay, so we're going to let W equal the number of white eggs, and let 3W equal the number of brown eggs, because there's 3 times as many brown eggs as white eggs. So our expression is going to look like this. W plus 3W equals 24. We're going to take that algebraic chain, and we can even put a 1 in front of that W because it's just 1W. 1W plus 3W equals 4W. And 4W equals 24. So we ask ourselves, what number times 4 equals 24? Well, I know that W equals 6. So what that means is that I have 6 white eggs, and I have 3 times as many brown eggs, so I have 18 eggs. Let's check our totals. Does 6 white eggs plus 18 brown eggs equal 24? 14, 24. It does. All right, I hate to cut you short right there, but of course I am allotted 15 minutes. So know that tomorrow when you come to class, we're going to play around with some word problems, and Mrs. Norton's going to take you into a group and put together some word problems and try to make algebraic chains. Thank you for watching the video. Have a great night, guys.